Yes, dear children, let us now go further to prepare aromatic aldehydes, benzaldehyde. Okay, how can you prepare benzaldehyde? Now you can prepare it from toluene. Okay, from toluene, how you can prepare? You can prepare it by a reaction called Itard reaction. And what do you use there? You use chromine chloride. CrO2Cl2 is called as chromine chloride followed by hydrolysis. Will give you benzaldehyde. Now from the same toluene, there are three ways you can prepare. You can also add acetic anhydride at a temperature of 273 to 283 Kelvin followed by hydrolysis. That way also you can get benzaldehyde. From the same toluene, you can also do by halogenation. Chlorine in the presence of sunlight, that way also you can use, followed by hydrolysis. Not only this, followed by hydrolysis. First one is this and then hydrolysis. Now apart from this, you can also prepare it from benzene. From benzene, you can prepare it by means of Gatman-Koch reaction. Gatman-Koch. We studied one Gatman reaction also along with Sandmeyer reaction. Sandmeyer reaction is preparation of chlorobenzene, bromobenzene or cyanobenzene from diazonium chloride using copper salt. Okay, whereas Gatman reaction was same benzene diazonium chloride से chlorobenzene बनाने के लिए you are using copper powder and HCl. Okay, now this is Gatman-Koch, where benzene is converted to benzaldehyde in the presence of carbon monoxide and HCl in the presence of anhydrous aluminum chloride as catalyst. Now apart from this, you can also prepare it from benzoyl chloride by adding hydrogen in the presence of palladium and barium sulfate as catalyst, and you can get benzaldehyde. Again, I remind you what is the role of barium sulfate here. It is smeared over palladium so that further reduction of benzaldehyde to benzyl alcohol is prevented. So this is acting as a catalytic poison. What is this reaction called? This reaction is called as Rosenmund reduction. This is a very, very important reaction. Okay? Rosenmund reduction. Then you have one Gatman-Koch reaction. And then you have Itard reaction. These are the three named reactions under aromatic aldehydes. Now, one by one, let us go. The first one, what? It was Itard reaction. That is done in the presence of chromine chloride, is it not? Okay, now what is chromine chloride? CrO2Cl2, I told you. CrO2Cl2. Cr double bond O, then two Cl atoms attached through single bond. So this is what is called as CrO2Cl2, that is chromine chloride. Now what is happening? This toluene, it is reacting with chromine chloride in the presence of carbon disulfide as solvent. See how it is getting attached. Out of the 3 hydrogen atoms attached to this carbon, 2 hydrogen atoms are going to be replaced by the derivative from chromine chloride. Okay, so you know very well that Cr is attached to 2 oxygen, is it not? Now 1 oxygen is going to be attached to the benzyl carbon, and to the other oxygen you are going to add one of the hydrogen from here, so it has become OH. Then you have ClCl. Same way it is attached. Another molecule of chromine chloride is attached through oxygen, and the other hydrogen atom is attached to the other oxygen which was attached as OH and ClCl. So this is the intermediate that is formed after the addition of chromine chloride, which will undergo hydrolysis. Okay, so when this is undergoing hydrolysis, what is going to happen? This will be removed. This bond will be cleaved, and this bond will also be cleaved. So on hydrolysis, what will happen? Hydrogen on one side, OH on the other side. So this will become CH, OH बन जाएगा ये, Now from this, one water molecule is released and you will get CHO. बेंजाल्डिहाइड बन जाएगा यहाँ से. ठीक है. So this is what you call it as Itard reaction. Now by halogenation also you can prepare. How it is done? Toluene is treated with chlorine in the presence of sunlight. Remember, when there is sunlight, then it is substitution. Benzyl hydrogen is substituted. So there is possibility of 2 hydrogen atoms of benzyl carbon substituted by chlorine. And this on hydrolysis, both the chlorine will be replaced by OH. And from that, one molecule of water is released and you will get benzaldehyde. Is that clear? This benzaldehyde only I wrote it here, right? So toluene, then a dichloro derivative form, and then that is replaced by OH, and then on removal of water you will get benzaldehyde. Okay, so this is from toluene. Now what about the other one? The other one is, okay, this is with acetic anhydride. Okay, now in the case of acetic anhydride, what happens? The same way, जैसे आपने chromine chloride किया था, same way what is going to happen here? Acetate group is going to be attached. Acetate group in the sense, you have toluene in the presence of acetic anhydride, CH3CO twice O. Okay, so just see CH, now here O, CO, CH3. Same way O, CO, CH3. So acetate group is attached. Okay, in the presence of CrO3. Now this is an oxidizing agent. This will provide an oxygen. Then CH3CO. CH3CO तो 2 है आपके पास. Now एक ये वाला oxygen एक आ गया. Now oxidizing agent is giving another oxygen, so another oxygen आ गया. So what is this called? This is called as a gem diacetate. Acetate group attached to the same carbon. So it is called as gem diacetate. What gem diacetate? Benzylidene. Gem diacetate. Okay. This is a non-oxidizable derivative. This is a non-oxidizable derivative. It's a very, very important concept. You need to know that it is non-oxidizable derivative. This on hydrolysis, in the same way, first initially this will become CHOH. From this water is released and you will get benzaldehyde formed. Right? So what has happened here? Toluene is first treated with acetic anhydride in the presence of CrO3. This is an oxidizing agent. So you're getting a benzylidene gem diacetate. Diacetate is added like this. And this will undergo hydrolysis to give you CHOH twice, which on removal of water will give you benzaldehyde. Okay, so this is another method of preparation. So we saw 3 methods, right? One is Itard reaction, then by using acetic anhydride, and the other one by halogenation. So from the same toluene, there are 3 ways by which you can get the benzaldehyde. Then this COCl, Rosenman reduction, you already know it, is it not? So you have, say, RCOCl plus hydrogen. When you add, so RCHO plus HCl. One hydrogen will go with Cl as HCl and another hydrogen will get incorporated along with carbon. So you will get RCHO, or here it is benzaldehyde is formed. So these are the methods of preparation of aromatic aldehyde. Now, how this Gatman kosh, how it is done? Carbon monoxide plus HCl is going to give you formyl chloride. Okay, HCOCl. This is what you will get. And this HCOCl will react with AlCl3, which is acting as a catalyst. Now you know it is a loose acid. This loose acid will take away the bond pair of electron along with Cl and become AlCl4 negative, leaving behind HCO positive. Okay, so this is what is left. And this will react with benzene, giving rise to benzaldehyde. That's it. Okay, that is Gattermann-Koch reaction.